Okay, so the next major self-controlled design that I want to talk about is the case crossover. Now, this is similar to the self-controlled case series in as much as everybody that's included in the study has had the outcome of interest. They haven't all had the exposure, but they have all had the outcome. And again, each case of the outcome acts as their own control, and we define several periods before the outcome as either a case or a crossover period, and we compare the risk of exposure during the case and the crossover periods to see whether people were more likely to be exposed during the case period than some other previous crossover period. And I'll show this on a cartoon. So again, we've got somebody's observation time here. They have the outcome at this point here. We can then ignore everything that happens in the future. So this is quite different to the self-controlled case series where we were allowing people to remain under observation. So we stop observing people at the outcome, and we will look at this case period and see whether they had the exposure we were interested in, but we will then also look at potentially one or more control periods earlier on to see whether they had the exposure then. Yeah, so relatively straightforward, a bit like a case control study, but where everybody is their own control. Yeah. So in its simplest form, we just have one crossover or control period, and we contrast that with the case period. So you could, in theory, do a case crossover study just with a calculator. You don't need any fancy statistical software at all. That's all you need. The example I'm going to tell you about is one about benzodiazepines. So these are drugs like Valium, which they can cause drowsiness, and this is well known. The research question was, does being prescribed a benzodiazepine increase your risk of having a road traffic accident? Okay. So confounding is likely to be a problem in this study question. If we wanted to use a conventional design like a cohort or a case control, the worry would be that people who are prescribed benzodiazepines are very different to people who are not prescribed them, and that maybe the indication for a benzodiazepine, such as anxiety, may also be associated with road traffic accidents. So finding a good comparator group for this question, I think, would be very difficult. So the study that was done was in a small region of Scotland, which is in the north of the UK, and this was over a 3-year period where they were able to get full prescription data for everybody who lived in that area. And they found that 20,000 people, or drivers, were involved in a road traffic accident during that period. Now, this region of Scotland is quite small, so I would say if you ever visit the Tayside region, just be careful if you're crossing the road, because if they have 20,000 car accidents in 3 years, I think that's not great. Anyway, the day of the road traffic accident was the case period. So we were interested in whether or not they were receiving a benzodiazepine on that day. The investigators compared that with the risk of receiving a benzodiazepine on the same day of the week during the 18 weeks before the road traffic accident. Why do you think they chose the same day of the week?
If it's a work day, they go to work, and or in the weekend we go to supermarket, like those.
Yeah.
The similar situation.
Yeah. So that we're comparing similar behaviour patterns on similar times of the week. Yeah, exactly.
Would the weather be a confounding factor?
Weather could be a confounding factor, yeah, that's a really good one. I think that would be more of a problem if everybody was having their RTA on the same day. But there could be some problems with, they may have been more common on some days of the week. Yeah, that's actually a really good point. No one has ever asked me that before, and I don't know that the investigators took that into account, but actually it's a really good point. It would have affected the road traffic accident Whether it would have affected whether somebody took a benzo that day, maybe less certain, but it's a really good point. With all of these self-controlled methods, the really key thing is to think what else could change over time and that I might need to account for in the analysis. Yeah. Okay, so in a cartoon style, this is the design. That's the day of the accident. And we see, did they take a benzo on this day? And then see for all of these previous 18 weeks, did they take a benzo on any of those days? So they found that 235 of the drivers were taking a benzo on the day of the accident, and that on average, only 147 were prescribed a benzo on one of the other non-road traffic accident days. And so the within-person odds ratio was 1.62. So in other words, yes, there did seem to be an increased risk of having an accident if you were taking a benzodiazepine that day. Okay, so in lots of ways, this is a more simple design than the self-controlled case series. It makes fewer assumptions. It also, I haven't got time to go into it particularly today, but it does assume that the risk within the whole population of receiving a treatment is static over time. So if we go back to this example here, let us imagine that rather than weeks, this was years. So if this is 18 years before the road traffic accident, let's imagine that the rate of prescribing of benzodiazepines has changed drastically over 18 years, and that everybody in the population is more likely to be prescribed a benzo here than they were there. It would mean that I would find an artificially increased risk associated with having the outcome. So there is an assumption that the rate of prescribing in the population is the same over the time period. This isn't the case for the self-controlled case series. It doesn't matter for that design. Okay.